All right, welcome to the day of our last new material until before the exam. Okay, yeah. So we're going to take a look at the product and quotient rules. Bottom line is that they're kind of a formula that we'll follow. I'm going to introduce them a little bit to get there, but today's very sort of an abstract, just sort of a skill-based, a new way, another way to take the derivative when we have two functions being multiplied or divided. Thursday we'll go into a full day of review, and then we've got our exam. Wednesday. Monday we have our exam. This place, same time. If you can, if it's possible to get in here a little bit early, try to get here by 5 minutes early for the exam, just so that you can get seated. If not, maybe we can. I imagine it'll be fuller. It should be pretty full, I would assume. We'll pass out the exams, and take the exam and go from there. I saw in my email I just received a copy of the exam, so I'll be reviewing that tonight, and we'll let you know.
Are you going to post any practice exams?
There is a practice exam already posted in Canvas. There's also, well, let me get to there. Before I go to that, though, I moved the topic 11.4 from my Tuesday, Thursday class and said, let's just do a day of review. We'll squinch up after the exam. It doesn't do much good to cover a really complicated thing that's not on the exam just before the exam. So we've got 2 days of review in my Tuesday, Thursday. It's a 7:30 class. If any of you want to come, you're welcome to show up and get some additional review. Nothing overly special, just a chance to answer some questions. So it's a morning, 7:30 in the morning. So yeah, that's why when I'm done here, I go back home and go to sleep till the next day. So then early morning. It's in SCOB 252. So, and it's in the syllabus, so you could pull up their syllabus in here if you're interested, or just if you're really interested, just let me know and I'll give you all those details. So there's 2 day review days here. There's a review day here, and then maybe over the weekend, if there's a call for like a Zoom meeting. I will record them just like I do with every class, and yeah, I'll post them up so you'll get the benefit of questions that anyone else has. So primarily what we'll focus on, let's see, is so here for the learning materials for 1, there's this review down here at the bottom. So just underneath 11.3, which we're doing, there's the exam 1 and the solution guide. So it's a PDF. And there's also this link to the ASU's math department's MAT210 website, which they have one for each class. And that's where these are posted as well. So they're posted there for test 2, test 3, and the final exam. I'm just making them available here as well, a little bit easier. But you can always go there, and some of the classes put additional resources. I just saw these exam reviews. So that's a good thing to be going over. Not so much focus on the homework, but these, and again, I'll review the exam and make sure we're getting in the review the things that are really important. But it's a pretty good indicator. They give a lot of different types of problems, and typically there'll be at least one question from each sort of section. So we'll get through that. So again, if we have x to the power of 3, how do we take its derivative? The power comes down, multiplies in front, so that's 3x. We subtract 1 from the exponent, so the 3 becomes a 2, 3x squared. If we can do that, we can do this. So The way of taking the derivative is going to be the same process we have been doing from 11.1. 11.2 was an application of marginals, which is a derivative that we were doing the same thing with those derivatives. And the thing that will change here is that we have to do it sort of in pieces. But if you can just remember, all we have so far, we're not doing any exponentials or logarithms or any other funky stuff. It's all polynomials. That exponent comes down in front, and we subtract one from the exponent. That's all we're really doing. We're just going to add a little sort of extra to this, and not too much bad. So let me take a step back to algebra to give a comparison. This is not calculus, this is algebra. So if we had x plus 4 times x minus 3, so that's algebra, we're just being asked to multiply those two together, right? Now when you first saw that, maybe middle school, maybe high school, maybe you've never seen it before, I'm sure you've seen it somewhere. You might be tempted, oh, let's multiply the x's, let's multiply the numbers, but we found out, hopefully at some point, that to do this, it was really, we needed to multiply the first two together. It gave us x squared. We multiplied the outers together, which is getting us to FOIL, minus 3x. We had to multiply the inners, and then we multiplied the lasts, which gave us minus 12. And then we did a little bit of algebra of adding like terms. And then we were done. Okay. That's kind of what we're going to need to do today. So let's just, since we've got this, we've already got it multiplied out, right? If we were to take the derivative of x squared plus x minus 12, what would we get? Well, actually not this. The derivative of this equals what? Two comes down, 2x, subtract 1, 2x to the first power. Derivative of x is 1. Derivative of negative 12, 0. Okay, so now we know that this derivative is supposed to be 2x plus 1, because we've done these kind of things, right? Just take a quadratic, take its derivative, no problem. The question I'm going to ask is, could we do it directly before we multiplied out? And of course the answer is yes, because that's what the title of the chapter is, product rule, so we're going to get a product rule. But let's go with maybe our gut feeling for an intuitive way. It's going to be wrong, so I'll let you know that out, so don't take too curious notes, but I'm going to do it wrong, but it kind of feels right just to get this out of the way. It might feel right to, let's just take the derivative of x plus 4 and then separately take the derivative of x minus 3, and then let's just multiply those two together. Well, derivative of x plus 4, derivative of 4 is 0, derivative of x is 1. Same thing happens over here, derivative of x is 1, derivative of negative 3 is 0, so we end up with 1 times 1, which is 1, but that doesn't look like 2x plus 1, does it? So there's something we're not doing the right process here. Thinking of FOIL, what might be a good way, and again, we'll introduce it formally, and just remember all of these things that we do took sometimes hundreds of years for people working on their, academically to figure these things out. What we see is that there is a first expression, I forget the, and there's a second expression. So I'll just call them F and S, first and second. What if, just for chances, what if we took the derivative of the first one and then we multiplied by the second one, but we didn't take its derivative? And then we added to it the first one, which we didn't do anything to, and we multiplied by the derivative of the second. You'll see that this works, but it's just kind of like, how did they come up with that? They probably tried a bunch of different things, but we know what the answer is because we've multiplied out. The thing is we're going to want to know this rule, how it works in general. So we're going to be doing some that actually would be easier probably to just multiply out and come up with the answer if that's all we needed. But later on, we're going to need to know this process because we're going to get some that we can't just FOIL out and it's easier that way. It'd be harder. So that's why, that's the motivation for this. Yes, we did it. It would be easier to multiply and just get it. We know we're looking for 2x plus 1. Let's see if this works. And this is how they probably just, figured this one out. So what we do is we take the first one, and let me kind of go over here. I like to just kind of make my pieces. My first one is x plus 4. Well, what's the derivative of x plus 4? Well, we kind of did that, right? Derivative of x is 1. Derivative of 4 is 0. So derivative of the first part is just 1. The second part, the second factor, is x minus 3. And so notice I'm getting all my pieces lined up here. And then the derivative of the second also is just derivative of x is 1. Derivative of negative 3 is 0. So that's all there is. Now let's put it together with this formula. The derivative of the first one, well, let's change colors, is 1. The second one unchanged, well, that's just x minus 3, plus the first one unchanged, x plus 4, times the derivative of the second, which is just 1. When we do this, we distribute 1 through, we get x minus 3 plus x plus 4. When we combine like terms, we get 2x plus 1. And all of a sudden, if we think that's the derivative, we have some confirming right up there, right? That's what the derivative is supposed to be. So I just want to show you this. This is all we really needed to know today. Here's the formula. If you're multiplying, take the derivative of the first factor times the second one unchanged, add together first one unchanged, derivative of the second. That's it. And we're going to see the quotient rule really follows right in track. We just got a little piece more to add to it. But that's all we got to be able to do. Notice we didn't do anything new as far as when we took the derivative over here. This is just take the exponent down, subtract 1. It's just we've got to organize it correctly. Let's see. Quotient rule, I'm going to skip that for now. So here's the formal rule for taking the derivative of a product. So if I need to take the derivative of some function times some function, again, I use f and s, they use f and g. Notice derivative of the first one times the second one unchanged plus the first one derivative of the second one. So I just want, because that's kind of a small marker just to see that we're just taking the derivative of each of them, but how we put it back together is important. Okay, so it's going to be basically two terms added together. Any questions, or is that? Okay, so we'll do a few examples and ones that are maybe a little bit more complicated than multiplying out. Okay. So here's one not too bad, right? And again, I'll just go, here's my first term, here's my second term. So I will always do this. I'm going to go first is x to the third. The derivative of the first is 3x squared. The second one, or you could use g, whatever you want to use, is 1 minus x squared. Again, it's just copying it over. And then the derivative of the second one, derivative of 1 is 0. Derivative of negative 2x is of negative x squared is negative 2x. My brain thinks so fast I can't I go beyond. All right, and then if you'll get in the habit of each time you do this, if you'll write down the formula, I mean, I maybe have it somewhere else too, but as you write down, what ends up happening is you're remembering the formula, not memorizing. I have a very hard time trying to memorize stuff. If I sit down and try to memorize, it doesn't stick, or I don't know, it just doesn't work for me. It might work for you, that's fine, but I found if I just every time write it down. Remember, when you're using your hands, what's that doing? It's taking the brain and moving it up like in here. And up here is where your math stuff is anyway, so it's getting the part of your brain active that needs to deal with things. So the more things you're doing, the better it is. So the derivative of f times f, I'll just kind of, and we can use this one or the other one. Derivative of f times s plus f times the derivative of s. Oops. See, that's why I also need to write it down so many times is derivative. So derivative of f is right up here, x to the third. So notice I'm not really doing any I'm just really copying things down in the right location. And then I multiply by s unchanged, which is 1 minus x squared. And then I've got an addition. I take the first one. Yes, sir.
Wouldn't it be 3x to the next to the third?
Oh, thank you. Wait. No. Oh, yes, because it's the derivatives. Make sure you got your pieces. Make sure you write the right pieces. Thank you. Thank you for keeping me on track. I got here and I felt that maybe it's the heat. I just felt so sleepy, and so my brain's half asleep. Thanks for waking me up. Thank you. But again, also the importance of showing your work. I know on the exam from teaching this class before, there'll be a portion that's multiple choice. So all you have to do is circle the right answer. However, if you can provide your work, if you circle the wrong answer and I can see, oh, you made a blunder like that, I can give some partial credit. So just keep your work there, and we'll get it. So thank you. 3x squared, exactly. And then this one, let me be more careful, is f. So that's the one that's x to the third. And the derivative of s is negative 2x. Okay. So now it's from here, we've done the calculus, we just now do the algebra, right? And then like terms. So I'll do 3x squared times 1. 3x squared times negative x squared, that gives us negative 3x to the fourth. Over here, we're going to get negative 2x to the fourth. We have some like terms we can combine. So we get 3x squared, negative 3 and negative 2 is negative 5x to the fourth. And this one is simple enough, you could actually do a double check. You could distribute that x to the third. Yes?
What happened to the one in the original?
It's right here.
For the, yeah, for the
Oh, it became 0.
oh,
So when it gets 0, so yeah, you could write it 0 minus 2x and then it just disappears. Good question. Thank you. Because those are the things. It's a simple question, but it's not. It's the simple things that get us. It really is. It's the foundational things. Like you said, organize and then copy down correctly. So good. Any questions? And again, we could have just distributed the x to the third and we'd see we would have got the same thing, right? But the reason we're doing this is it's going to get more complicated. We're going to do things that are a little bit more complicated. Something maybe like this. But actually, it's almost just as complicated to use the product rule, but okay. So again, we choose a first one, and there's the second one. So first one is 2x squared plus x. The derivative of the first one, 2 times 2 is 4. X to the first power. Derivative of x is 1. Derivative of 1x. We good there? The second one, I write it down, x minus x squared. And then its derivative, derivative of 1x, derivative of 1x is 1. Derivative of negative x squared is negative 2x. Okay, so we've got our two derivatives, we've got our two functions, we put them together, and again, if you write down the formula, you're building this memory, and it becomes a little bit more natural. So derivative of y is going to be f times s plus f times derivative of s. See if I can do this right this time. So I get 4x plus 1. Derivative of s, oh wait, no, not derivative of it, just s. It's going to be x minus x squared. The original f is 2x squared plus x. And then the derivative of s is down here, 1 minus 2x. Okay. Now the nice thing is this is the derivative. We've done the calculus. Our calculus is good, right? The rest from here is algebra, just reorganizing. But this is a good place to just say, hey, I've got the derivative. And again, sometimes we're going to get ones that are fairly complicated. We might not even need to multiply them out because we could graph this. We could use this derivative if we needed to. But we'll go ahead and do some algebra on it. Foiling out, we get 4x squared minus 4x to the third plus x minus 4x to the third. Wait a minute, I did something wrong there, so I can't even get my FOIL right. Oh, thank you. Yeah, I see what I did. Multiplied the same ones twice. So it's this one that goes there, not this one. So 1 times negative 2x, or negative x squared. Did I get that right? Okay. And then the second part here, let me change colors. I think that helps me. 2x squared, so I got this plus here. 2x squared minus 4x to the third plus x minus 2x squared. Yeah, changing colors has always helped me. In fact, when I was taking these classes, I got a 3-color pen, and when I started changing color, I did a lot better. So that's helpful. You could do that. Bring as many pens or pencils to the test as you want. You can bring highlighters, whatever you need. Okay, let's come back here. So I've got to see how many x to the thirds. I've got this x to the third, this x to the third. So minus 4 and minus 4 should give us a minus 8 x to the third. Now x squared, I have a 4x squared. I have a minus x squared, a plus 2x squared, and a minus 2x squared. So this one and this one will cancel, right? 4x squared minus x squared should be a plus 3x squared. And then I have a plus x and a plus x plus 2x. I think that's all there was. Making sense? Again, really nothing as far as taking a derivative, nothing new as far as the process of the derivative. Over here, we're just doing the same thing. It's just that now we've got this formula, and we have to multiply the derivative times the other one, the derivative times the one unchanged. Okay. So complicated, but one of the other pieces of advice I'll give you is give yourself plenty of room. I realize, as you see me, I kind of crunching on here, but a lot of when I make mistakes, and I make a lot of them, is sometimes I just don't, I'm trying to save paper. If I would give myself a little bit more room, I'll make less mistakes. So using color, giving yourself room, and slowing down. And not trying to do two things at once. So I'm trying to talk to you, and I'm trying to do the, and you'll see I mess up my math all the time. So, good. Questions, comments? You okay? The other thing, I just kind of, by tomorrow morning, I'm going to post some videos. There's a way to use your calculator to find things like the slope of the tangent line. If you have a TI-84, Casio, or the numerics, I'll do brief videos on how to do a few technical things that may help you.
How did you get that 3x squared?
I'm not sure. That's okay. So 3x squared. There's a 4x squared here. There's a minus x squared here. So there's 3x squared, and then those two canceled. But again, I'm always, even when I'm really confident, I'm only about 90%. There's still, I always realize, if you ever get to 100%, you're probably wrong. At least that's what I found out. Here's an example from the text. Again, this was from spring, so I don't know if you'll see this exact problem still or not, but you might see something similar to it. It's going to bring in this idea, why do we need to take the product of a derivative? Because in business, sometimes we've got two functions that we need to multiply together to get some value, right? So monthly sales of Sunny Electronics' new sound system are given by this. So this is how much is going to be sold, these many units per month, T months after its introduction. The price that gets charged is given by this function. Find the rate of change of monthly sales. Okay, so that's just this Q function. So I'm gonna write Q down here, and you'll see that this one is actually walking us through the same thing we did, right? So we take this derivative, we're going to get 6,000 because the 1 comes down. The t is now t to the 0 power, which is 1. It's gone away. It's not 0. It's t to the, it's 1. So it's, whenever we have a single or something to the first power, it's just the coefficient. So that's that first derivative. The second part, the 2 comes down. So we're going to get negative 60 times 2 is 120 t to the first power. So that's that derivative. The derivative for the price. So this is a function, and again, remember in business there is, what's that thing, supply and demand. So the more supply, the less the demand, so that's going to affect the price. If you try to sell, if you flood the market with stuff, it becomes cheaper. If you keep it rare, it's more expensive. So I'm just going to write the P function down. I'm just copying 3,000 minus t squared. When we take its derivative, the derivative of 3,000 is 0. Derivative of negative t squared is negative 2t. Squeeze that 2 back in there. And now what do they want? They want revenue. Well, what is revenue? Revenue is price times however many you sell, right? So it's really just P times Q, but they want the rate of change. They don't want just P times Q. They want the derivative of P times Q, right? So what they really want so that's going to be the derivative of P times Q plus P times the derivative of Q. And as you see, this is commutative, right? multiplications commutative. We could do either order. Additions commutative. We could do it in any order. So if you want to do Q times P, you'll get the same. That's the cool part of all of this. So derivative of P is negative 2t. Q is this original up here. And then we're going to add, because that's the first part, right? And then we add P, which is 3000 minus t squared, times the derivative of Q, which is up here. That's going to be 6000 minus 120 t. Find the rate of change of the monthly revenue 5 months after the introduction. Well, we could FOIL all this out, but we're looking for 5 months, right? We could just plug in the 5 for t, save ourselves some effort, right? We've got the derivative here, put 5 in for t, we'll be able to calculate it, okay? And then down here, when t equals 5, the revenue is increasing at a rate of, so whatever number we got here, we'll go down here. Yes. Bottom. Actually, both of these. So it's this plus this, right? This is our derivative. Because they want the rate of change, we want to plug it into here. So you're going to get minus 2 times 5. 6,000 times 5, 60 times 5 squared, which is 25. Again, some of you might be doing this as you're coming along, but then plus 3,000 minus 5 squared, 6,000 minus 120 times 5. Okay, that's just an arithmetic. I'll leave that for you so that we have our fresh brain because we're going to go into the quotient rule. Yes? Oh, it was right here. I know. I looked at the bottom one and it said t equals what? I go, how am I supposed to know? Oh, I read the question that I saw it. So I'm with you. I didn't know at first, and then I went back and find the rate of change in the monthly revenue 5 months after the introduction. Yes?
And then once I solve it all out, that'd be a rate per month.
That's the rate per month, yes, because it's a derivative, so that's the rate of change. It's not the revenue. If you want the revenue, then you take P times Q without, before you took the derivative. But they want to know how the rate's changing. Again, maybe they need to change something. Yes?
How would you solve it if it was like FOIL? Would you just so after the FOIL, would you just put 5?
Yeah, we would just, you could do that. You could multiply it out and then put in 5 for t, but however you want to do it, yeah. Or just plug it into a calculator and then go to the table. When x is 5, what is the output? But that's what I mean. Sometimes we don't need to do a bunch of algebra to get to our answer. We're just going to plug, if this is all we're going to do with it, rather than doing the algebra, because I guess, that's probably where I would make a mistake. And so, we'd have to FOIL here, we have to distribute here, then combine like terms, and I'm just going to plug in 5 and get a number anyway. I would just go for something like this. Okay. But again, today's lesson, the main thing we're looking at is how do I go about applying the product rule, and this is the product rule. Okay, how do I take that derivative, and we got this, and then you'll get some applications. Now, I could explain the quotient rule if we knew what the the chain rule is, but we're going to do the chain rule later, so we can't really explain too much. But all I do is I'll say, it'll kind of explain why we get this g squared here. But notice it's sort of just like the product rule in the top, except instead of adding, we're subtracting. And why are we subtracting? Because this is really f of x times g of x to the minus 1 power, right? We could move that function up by making it to the minus 1 power. And we've done that enough. So that kind of explains why we have, and then we're just, if we apply the product rule, we'd have this, and this negative is becoming, because when we take this derivative, that negative comes down, right? And then using the chain rule, we see, remember, this kind of explains it. If I have x to the first 1 over x, right, that's x to the minus 2. When I take its derivative, I get, oh no, it's x, it's x to the minus 1. I'm jumping ahead of myself here. But when I take its derivative, negative 1 comes down, x subtract 2, I get negative 2. This is going to become negative 1 over x squared. Okay, so that's the quotient rule is coming, because if I were to move this up and do it, this is coming from the negative exponent, and this is coming from the negative exponent. Again, when we go to do these, we just need to remember this formula. But notice it really is identical to the product rule in the top with this subtraction instead of addition. And then we just have to remember, since we are dividing, we divide by whatever was there gets squared. Okay. And again, we'll write this down each time, so that will help us remember what we're doing. We'll remember the formula. I'll look at the test, but I don't think they provide it in the test. So, and again, you could approach this differently. You could go with negative exponents. There's ways you could do this without the quotient rule. But the reason we're doing this is, as we go forward, we're going to get times when we have to use that quotient, or the quotient rule is actually going to be easier to use. And this might be the case. So for this one, I like to use t for the top and b for the bottom. You could use n and d, but numerator and denominator, those are kind of strange words. I just go with top and bottom. So what I do, again, here's the top, x squared minus 3. I need to take the derivative of the top. That's just 2x. Then I go with the bottom. Bottom is x to the 4th. And then the derivative of the bottom is going to be 4x to the 3rd. Now I just have to go back, take a look at that formula. And again, I like to use t and b, whatever you feel comfortable, remembering it the way you want to use it. It's the derivative of the top times the bottom unchanged minus the top times the derivative of the bottom, all divided by the bottom squared. Okay, I got all my pieces up there. I just have to fit them into this formula now, and that's going to be its derivative. T derivative is 2x, and the bottom is x to the 4th. Okay, minus. Now this is sometimes where I mess up, because that when I have a plus, I can do it in any order. I'm okay. Plus, I don't really have to distribute it. But remember, if I get something that is in parentheses, I'm going to have to distribute this negative through. I have to subtract the whole thing. So the one thing I've learned is to go ahead and sort of do this with parentheses, simplify as I go, and then I distribute that negative as a last step. Otherwise, I mess up horribly. And if you watch the video from my Tuesday class, I did. And I couldn't even, I had to redo it, because I said, I don't even know what I did. So the top is x squared, so I'm going to put this here. x squared minus 3, a small parentheses, and the derivative of the bottom is 4x to the third. And then, so that's the top. The bottom is going to be the bottom squared. So that's x to the fourth squared. Now sometimes if this was like a monomial or something, or something we'd have to square out, you could just leave it squared. This one we'll go ahead and do it because it's 4 times 2, right? That's going to be 8. Be careful your exponent rules. Again, it's the simple stuff that gets us. Stuff from algebra from 15 years ago, whatever, we forget, and we put this and we say that that's 6 because we added instead of multiplied. I do it all the time. So, so in the front, we've got 2x times x to the fourth. That's going to give us 2x to the fifth. Minus, and notice I'm going to keep my parentheses. I'm going to distribute this thing first and then worry about this negative. You might do it in one step. Again, I blew it. So I got x squared times 4x to the third. So I've got 4x to the fifth. And then I've got this minus 3. This is where I messed up because minus 3 times 4 is minus 12x to the third. And then I like to change color, and I'm going to distribute this negative. So this 4 becomes negative, and this 12 becomes positive. And I've taken care of this thing now, all over x to the 8. And one more step. I've got a negative 4x to the fifth, and I've got a positive 2x to the fifth. That's minus 2x to the fifth, plus 12x to the third, all over x to the eighth. And we could just leave it like that. Again, you could also distribute this. There's, with algebra, the thing is when are you really done? There's sometimes you can take more and more algebra steps, but we're good enough. This would be a good answer. Heck, on an exam, if you get stuck, just stick with the simplest answer. I can see you took the derivative correctly. You might even get all the points, but certainly you'll get most of the points, even if you don't simplify. Okay. If you do the part, they said find the derivative. That is the derivative, right? This is the algebra. This is simplified or whatever, but so don't worry about going too far. Yes.
If you simplify and you get the answer wrong,
As long as you've got this as evidence, then I might take like 1/10 of a point out of 10 points. It'll be a very minor. Okay, we should do something because you have 2 plus 2 and you got 4, but might not. I might but show your work as show me that you've got a correct answer. If it's in the algebra, I'm not so worried about that part, but getting the correct derivative, that's the important part. Yes. Usually about 20. I haven't looked at it yet, but I will know by Thursday. I'll tell you that much. Actually, I'll know probably by 7 o'clock tonight, and I may post that later on. I want to get what I'm saying is I want to do a couple videos on calculator skills. I want to show you some things like it will find the tangent line for you. And there's usually at least one question that says find the equation of the tangent line. I'm going to show you where the calculator will do it all for you. It's very straightforward. And you could decide whether you want to use the other method or that. There's a couple other things I'll show you that the calculator can do that will help. Some maybe to verify, but I'll show you a few techniques that you may not have known. It will actually take its derivative. So I'll show you a few things. It'll be maybe a 15 or 20 minute video. I'll use the TI-84 first. I've got a Casio FX50. I'll use that one because the Casio works a little differently. And then I'll use the NumWorks calculator that I've got that's available as well. And I'll get those posted hopefully by maybe it might be tomorrow evening because again I got early morning, so we'll see how much I get done tonight. Okay. Just another one. Okay. Just quotient rule. right? Top and bottom. But this one, what you're going to see is if you've done the square root of x before, you're going to see it happen again. If not, if you're doing it for maybe the first time, we'll go over it. But so again, if I'm taking the derivative of the top over the bottom, it's the top derivative times the bottom minus the top times the bottom derivative over the bottom squared. So what do I need? I need to know what the top is. Square root of x minus 8. The derivative of this, well, derivative of 8 is 0. What's the derivative of square root of x? That's x to the 1/2, right? Square root of x is x to the 1/2. So the 1/2 comes down. And we're going to subtract 1 from it, but the way I subtract 1 is I subtract 2 over 2. 2 divided by 2 is 1. 1/2 minus 2/2 is negative 1/2. We'll oftentimes see this rewritten as 1 over 2 square root of x. Okay, and again, that's all. A lot of it's the algebra. Be careful. I was working with some, and sometimes if you're going to make this a negative exponent, move it up. Don't move the 2 up. The number stays there. Okay, and that's why the number 2 stays in the denominator. And this was actually up in the numerator, if you want to think of it. But you might want to just, because you might be taking the square root of, or the derivative of the square root of x. Just sort of remember, if you do it a couple times, that's just 1 over 2x. So, so on an exam, you're not actually coming over here and having to go all these steps. You just say, okay, what's the square root of x? What's the derivative of the square root of x? It's 1 over 2 square root of x. Problem is, you do that enough times, you forget how to get to it, but you'll remember it when it's there, I guess, In the bottom is square root of x plus 8. And the derivative of the bottom, now again, this is, derivative of 8 is 0, derivative of square root of x, that's just going to be 1 over 2 square root of x. So we've got the derivative parts down, right? Put it into the formula. So it's up here, derivative of the top, 1 over 2 square root of x, times the bottom, which is square root of x plus 8, minus the top unchanged, square root of x minus 8, times the derivative of the bottom, 1 over 2 square root of x. And then what's in the denominator? The bottom squared, square root of x plus 8 squared. And this is one, you could expand this, but we're not going to. We don't need to. Okay, we're going to leave that alone. Up here, this is kind of a little bit of a messy thing, and especially because we've got a fraction over a fraction, right? We've got a fraction on the top. So one of the nicest ways to get rid of that is if we were to multiply by the denominator, which is 2 square root of x. So I'm going to multiply the top by 2 square root of x. But can I just do that, multiply the top by 2 square root of x? No. But if I multiply the top and the bottom by the same thing, that's like multiplying by 1. That I can do. So I'm going to do that. And when I multiply these two, what happens? 2 square root of x divided by 2 square root of x, that's 1. When I distribute it over to this side, 2 square root of x divided by 2 square root of x, that's 1. So it leaves the top looking really nice. I just got this square root of x plus 8 minus square root of x minus 8, so I'll take care of that. But in the denominator, I multiply, and that's what I'm going to get. Okay, so let me come down. Let me just do it here. In the denominator, we have 2 square root of x plus 8 squared. In the numerator, we have square root of x plus 8 minus, so this is going to distribute, right, to both of these. This becomes negative, this becomes positive. Square root of x minus square root of x, 0. Right, so I canceled out. 8 plus 8, 16. Maybe I'll do it over here because it was probably... So distributing this, I get minus square root of x. Distribute it to there, I get a plus 8. These two cancel, they become 0. 8 plus 8, 16. So the top part becomes nice. This part is just perfectly fine. Even if we were to do algebra on it, there's not much more that can be done. So this is our final answer. And again, if you'll go through the steps, especially this part, this is where the derivative happens, and then show me that you got this formula.
Can you go over squaring the bottom?
Squaring the bottom?
Yeah.
So that one, I just take whatever the bottom was, and I square it. I'm done. So I copied the bottom, put some parentheses, and put it squared. And usually, most of the time, that you're going to be done with it there. This part came from trying to simplify the numerator, right? Because I had to kind of simplify 2 square root of x, so I had to multiply the bottom by it. And all I did is I just tacked it on as a multiplication.
If you look at the function, wouldn't square root of x divided by square root of x just be 1? It's the same.
Right. You mean here? Oh.
The actual starting function.
Oh, but no, because this is minus 8 and this is plus 8, so you have to do order of operations since you can't cancel them here. Because otherwise you cancel and 8 divided by 8, so the answer's negative 1. No, that's not right. So, it'd be nice. That would be a lot easier if we could have, but it's a order of operations type rule. Good. We okay? So again, it gets a little bit, notice, didn't I tell you in the beginning if you could add or subtract 1, you'll be fine? That's the calculus part, but the difficulties are all going to come from the algebra. That's where the major difficulties are. And it's not going anywhere, which means that's the last slide for today. So that's the quotient rule, that's the product rule. We'll take a look at that. Thursday we're going to have a full review. Wednesday we're having a full review. And you're welcome to come to Tuesdays and Thursdays class, either one if you'd like. I'll give you the exact room number if you want.